Good evening. We are going to do today sine and cosine rule. Sine and cosine rules are the most important topics that are used in IB and IGCSE curriculum. So we will study the triangles, the sine rule and the cosine rule, and especially we'll be dealing with the triangle which is not right angle, non-right angle triangle. Okay, so let's begin. So, what are the topics that we are going to study today? First, first thing is the sine rule. Okay. And second one, the cosine rule, area of triangle as well. Area of a non-right angle triangle. Non-right angled triangle. So, first of all, triangle, which is not right angle in fact. So, let us draw a triangle. Let ABC be a triangle, and let us take side BC as A, means side opposite to angle A is taken as A, side opposite to angle B can be taken as B, and side opposite to angle C is C. Okay, so we have, according to sine rule, we have sine of angle A over A equals to sine of angle B over B equals to sine of C over C. And this will be an obvious constant. Okay. And how can we find the area of triangle if it is non-right angle triangle and just two sides and including angle is given? So let us try to find the area of triangle. So let's draw once again triangle ABC. This is side A, this one is B, and this one is C. Okay. So if we have this angle, let's say we have been given angle C. So angle C is given. It might be any measurement. Let's say theta. Okay. So area of triangle ABC will be half of AB sine C, or we can say half of AB sine theta. So area of triangle will be half of AB sine theta. If this angle is given, then it will be half of BC sine A. So try to observe it. What we are doing, half of, we are taking two adjacent sides and including angle. So by this method, we can find the area of any triangle if we have been given two adjacent side and including angle. Okay. Suppose we have been given, let's say, this is CQR. Okay. And this angle is given as alpha. And these two sides are given, let's say, these two sides are whatever. Let's say this side is R, this is Q. Okay. So area of PQR will be half of two adjacent sides are Q and R, obviously. So QR and sine alpha. This way we can find the area of any triangle. Okay. Now we will study cosine rule. Okay. And then we'll be doing some problems, some questions on the basis of these sine rules, cosine rules, and finding area of non-right angle triangle. So the cosine rule. Let ABC be any triangle. Obviously, this is not a right angle triangle. This is any kind of triangle, ABC. Okay. And let's take BC as side A and side B opposite to angle B is B and side opposite to angle C is C, small c. And so if we have to find angle A, so angle to find angle A using cosine rule. So according to cosine rule, cos of angle A, cosine of angle A will be B square plus C square minus A square over 2BC. Okay. So again, if we have been given the length of two sides and including angle is given, then we can find the third side. Okay. So let's say, and what about cos B, cosine B? Cosine B will be obviously A square plus C square negative B square over 2AC. And in this way, we have cos C equals to A square plus B square negative C square over 2AB. Once again, we draw a triangle. Okay. So let's say ABC again. So side opposite to angle A is A, side opposite to angle B is B, and side opposite to angle C is small c. Okay. So if these two sides are given, these two sides are given, B and C, and this including angle A is given, then we can easily find the third side BC, that is A, using cosine rule. So using cosine rule, A square equals to B square plus C square negative 2BC cos A. Okay. And similarly, if these two sides A and C are given and including angle B is given, then we can find side B, that is B square equals to A square plus C square negative 2AC cos B. And C square, this side AB, can be obtained by A square plus B square and negative of 2AB cosine the including angle C. This. Now we'll be doing some question. Okay. So let's take a question. This question is from, just a minute. Question is, this question is from HL, higher level, grade 11 IB board. And exercise number, chapter number 9, and exercise is 9.5.3. And question number 2. So HL IB board, exercise 9. A pole is slanting towards the sun and is making an angle of 10 degree to the vertical. It casts a shadow 7 meters long along the horizontal ground. The angle of elevation of the top of the pole to the tip of its shadow is 30 degree. Find the length of the pole, giving your answer to 2 dp. Okay. A pole is slanting towards the sun. So if we suppose this is sun, okay, this is sun. So slanting at 10 degree. Okay. So this is like, and this is 10 degree. Okay. Okay. Yes. So this is supposed to be 10 degree. And making an angle 10 degree to the vertical, it casts a shadow 7 meter long along the horizontal ground. Okay. It casts a shadow okay. Shadow, length of shadow is 7 meters. This is 7 meters. The angle of elevation of the top of the pole to the tip of its shadow is 30 degree. Means if you join the tip, okay, this is 30 degree. Find the length of the pole, giving your answer to 2 dp. Okay. So we need to find the length of, so if we take A, B, and C, AC will be the pole. So let us suppose, let AC equals to L, length of the pole. Okay. And C equals to 7 meter. The length of AB is 7 meter. The angle of elevation of the sun is 30 degree. So this angle has been given as 30 degree. We need to find the length of the pole, that is AC. We need to find L. So using sine rule, we can do that. One more thing we can do, since this is 10 degree, the whole angle, this angle is obviously 90 degree. Vertical angle is always 90 degree. Okay. So this angle, will be 90 minus angle ACB will be 90 degree minus 10 degree. That will be 80 degrees. Okay. So this angle is 80 degree. Now, if we take this side, BC as A, okay, and AB as C. What else given? A pole is slanting towards the sun, 10 degree to the vertical, it casts shadow 7 meter long along the horizontal ground. The angle of elevation is given, this angle is given, okay. The angle of elevation of the top of the pole to the tip of its shadow is 30 degree. Find the length of the pole and giving your answer to 2dp. Okay. So we have L over, so we need to find this angle. Na? So what we will do using angle sum property. Using angle sum property of triangle. Property of a triangle. So we have A plus B plus C, 180 degrees. Angle A is obviously 80 degrees. Angle B is given as 30 degree. So angle C will be what? This is 110 degree plus angle C equals to 180 degrees. So angle C can be obtained as 180 and minus 110 degree. That becomes 70 degree. So now angle C is 70 degree. Okay. Or since angle C is now we have been given, we can we can find the length AC using sine rule. So using sine rule, we have this C over sine C, C over sine C equals to L over sine B. L over, this is L AC. So L over sine B. C is 7 meter. Length of AB is 7 meter. So 7 over the opposite angle, sine of opposite angle, sine C, and C is 70 degrees. So sine 70 degree equals to L over sine B, and angle B is given as 30 degree, sine 30 degree. So we need to find L. So we have to isolate L, and the rest of the things can be taken on the other side. So L will be 7 sine 30 degree by cross multiplication, 7 into sine 30, okay, and divided by sine 70. So sine 30 is 0.5. We know that this is the standard value, okay, and we will use calculator to find sine 70 degree. So even normal calculator can work. So we will use normal calculator over here, okay. So okay, it will not work. Just a minute. So we have scientific calculator as well. So we will be using this calculator, sine 70 degree. Sine 70 degrees is 0.939692. 0.939, okay, and 69692. So Now, even normal calculator can be used. So we have 7 into, we have 7 into zero point 0.5, 7 into zero point 0.5, okay? That comes to 3.5 and divided by 0.939692. That comes to 3.724. So we have to take two decimal places. So we will just take 3.72 meter. This will be the length of the pole. We will take one more question, okay, to use cosine rule, and also we will find the area of triangle. So how to find area of triangle if two sides and one angle is given. So let's do this. Now, second question we are doing a triangular sandpit having side length 5 meter, 4 meter, and 8 meter is to be constructed to a depth of 20 centimeters. Okay. Find the volume of sand required to fill the sand pit. So we can construct a triangle because triangular sand pit is being constructed. Let's say this is A, B, C, and length AC. Let's say this is 5 meter, this is 4 meter, and this is 8 meter. Okay. So in this question, in fact, all three segments will be completed. First one, we will be using cosine rule. Okay. And then we have to find the obviously area of the triangle to find the volume. So first we shall use cosine rule, and then we'll find the area of the triangle, and then finally we will find the volume of the sandpit. Since this will be a 3D figure, however, we have just drawn a triangle which is a 2D figure. So depth is like here, some depth is there. So it's difficult to draw a 3D figure on the plain paper. So first we will just use triangle. So using sine rule, we can use, and let's say we are considering this angle, cos C. This will be 4 square plus 5 square minus 8 square over 2 into 4 into 5. Okay. So this will be 16 plus 25 minus 64 divided by 2 times 4 is 8 times 5 is 40. Okay. So this becomes 41 negative 64 over 40. So cosine C becomes negative 23 over 40. So angle C will be cos inverse negative 23 over 40. So if we use calculator, so this will become 125 degree and 6 minutes. Now to find the volume, we first need to find the surface area of the sand. So area of triangle, base will be area will be half AB sine C. Okay. So half into 4 into 5, the adjacent side and including angle we take, right? These two AC and BC adjacent sides and including angle is C. So area is half AB sine C. 4 into 5 into sine 125 degrees 6 minutes. Okay. So use calculator to find it. We will get 8.1815 meter square. So volume of sandpit. So volume of sandpit will be base area of triangle, base area, which is triangular base, okay, triangular, and times altitude, height, and height is given as 20 centimeter, constructed depth of 20 centimeters. So height is taken as 20 centimeter. So base area is 8.1815 times 0.2. So that comes to 1.64 meter cube approximately. This will be the volume of sandpit. Hope you understood it. Thanks for watching.